welcome back to another NumPy video. In this video, we're going to be talking about counting using NumPy. And in particular, the goal is to use NumPy to estimate probabilities. So we're going to use a lot of the same techniques that we talked about in our MATLAB unit about how to set up these probability estimate questions. So if you're a little bit fuzzy on that material, I highly recommend going back and watching those videos because the concepts from those videos will be used in this video. Otherwise, our goal is to use NumPy to estimate a probability, and in particular, the question we're going to estimate the probability of is, let's say I have an array of random integers between -50 and 50, and let's say I pick a random integer from such an array. I want to know, well, what's the probability that the number that I pick is strictly less than 10? So here I have a number of steps kind of showing how we're going to break down this problem. So to get started, let's start by first importing NumPy. And then let's also create our random number generator. So we're going to say RNG equals np.random.default underscore RNG. So here's our random number generating object. And now let's start by first just creating an array of random integers between -50 and 50. So remember, the larger a number that we use, so the larger an array we use, the more accurate our probability estimate will be. But while we're setting up the problem, let's just say I have an array with 20 elements. I'm going to call the variable n, so that later when I update this to a larger number to estimate the probability, it'll be easy to change in just this one spot. So let's start by creating this random array. So this is a reminder from a previous video. How could we do this? Well, I can say ARR equals RNG.integers. Now remember, I want to include 50 here. So the way that works is I go -50, and if I put just 50 here, remember that would go up to 49 and include it, but not include 50. So if I put 51, it'll go up to 50 and include it, but not include 51. So start at -50, go to 51, and let's let the size be equal to n. And if we want, we can take a look at ARR. So we can see here, -27, 27, -1, 31, -45, and so on. Now, because I'm going to do these computations using a NumPy array and a list, let's quickly cast this NumPy array to a list. So I'm going to call myList equal list of ARR. And quick note I want to make here, you might be wondering, why do I call this myList instead of something like just list? And one hint is that notice if I remove myList, then list here gets highlighted in green. So what that means is that list is already built into Python. So if I put list here and run this code, it's going to overwrite list and things aren't going to work the way I expect. So when you're kind of naming variables, especially when you're first getting started, it's best to use a somewhat random name. So my list here, I can kind of rest assured that this isn't overwriting anything that's already in Python. I know ahead of time that ARR works just fine, but again, when you're getting started out, calling it things like my list, my array, that's usually the safest bet. So here we have my list, and now, okay, so it looks like we've taken care of part A. So we have a random array of integers between -50 and 50 inclusive. Oh, and this is a nice example too, because notice here we did get, well, I guess -50. I want +50. So let me try running it one more time to see if I can get an example of 50 showing up somewhere here. Nope, maybe one more time. Nope, but it's okay. We can rest assured that 50, it is possible for it to show up in this list because we're going up to 51 here. So now what we want to do is we can start to answer the question, well, how many of the integers are less than 10? So I'll show you 3 different ways of doing this. The first way is going to be the way that we're most familiar with, and that's just using a for loop. So I'm going to initialize a variable called count to 0, and I'm going to say for x in my list, if x is smaller than 10, I want to increase the count by 1. So I could say count is equal to count plus 1, or an equivalent way of writing this is count plus equals 1. Now it can be really tempting to say something like else, oops, let's go out one, else, and then put count equals count, so meaning if I don't find something smaller than 10 to leave count alone. But notice this isn't changing count at all, so we don't need this else block. So I'm going to just run this for loop, and now we can take a look at count. And it's saying there's 14 numbers that are smaller than 10 in that list of 20 numbers that we picked, or that we generated. So that's using the for loop method. We could also do this using list comprehension. So again, good review of list comprehension. So I could say x for x in my list. Now pause and think about what have I kind of created at this point. All I've done is say take x for x in my list. So at this point, it's just the same as my list. So what I need to do is say if, and what do we want? X smaller than 10. And we can see here, this has returned the sublist of all elements from the original list that are smaller than 10. And we can see here negative 27, negative 1. Certainly these are all numbers that are smaller than 10. So I've shown you how to do this with the list. What about the NumPy way? So the way we're going to do this is I'm going to say ARR less than 10, and this is an example of what's called broadcasting. So hopefully you've seen the broadcasting video by now, but what this is going to do is you can imagine it takes 10 and it looks at every element of ARR and compares it to 10. So it's going to return true if this is smaller than 10 and false otherwise. So let's take a look. So you can see here, 36 is not smaller than 10, so that's false. Negative 29 is though, so that's true. 42 is not, so that's false. So you can see here we have this Boolean NumPy array where it's false everywhere the element in the original array was larger or equal to 10 and true otherwise. So one way that we could count all of these is we could say np.count underscore non-zero. And notice here, so kind of typical conventions, false is going to be counted as 0, true is going to be counted as 1. So this is going to count all of the trues. And I'm going to say ARR smaller than 10. And we can see here, this has given us 11. So something we should be a little bit suspicious of. What is that? So when we called count here, we got 14. So maybe I ran ARR. Oh, I think what happened is, so remember I had run ARR a bunch of times earlier to see if I could get 50. Let's update everything all together and hopefully our counts match. So there's ARR, there's my list. Let's take a look at my list really quick. So let's see, 36, negative 29. So that's looking good. Now let's run the for loop. Okay, there's 11. Now let's do, I should also count or do length of this list comprehension, so I get a length. So that's length 11. Ran this again, and now run again, and we also get 11. So good reminder that I had kind of called array, which depends on this rng.integers, but not updated my list. So that's the discrepancy. But we can see here, everything matches as we would expect. So here we used np.count underscore non-zero. What else do I want to say about this? I think this is good for part B of the question. Now let's try part C. Now for this one, I'm only going to talk about how to do it the NumPy way, just because it's not something we're going to be working with too much, just an example. So the way we can do this is we can say np dot, instead of count non-zero, we'll just say non-zero, ARR less than 10. And we can see here, notice, important thing to keep in mind, is it returns a tuple where the first element is this NumPy array that contains the indices where elements of ARR are smaller than 10. So notice 1 tells me at index 1, I have something smaller than 10. So where's ARR? So this is index 0, this is index 1. Index 2 should not be included. Index 3 should not be included, but index 4 should. So notice here we have 1, 4, and then we could check the rest of them as well. So maybe it's a little bit frustrating that it's what's returned is a tuple where the first entry is this NumPy array. It will be more useful when ARR is a two-dimensional array. So keep in mind ARR here is just one-dimensional. If we're kind of dealing with arrays that have more than one dimension, this tuple that's returned will be a lot more useful. So like I said, we're just going to do it the NumPy way. But now let's do part D. And I'm going to do this with all of the different ways that we've talked about so far. So I want to create a new array containing only these integers. So the way I'm going to do it is let's go back to our for loop. So here we were just counting what was less than 10. what I'm going to do instead is let's create a new list. So call it new list. I'm going to initialize it to be blank. Then what I'm going to do is I'm going to say for x in my list, if x is smaller than 10, what I want to do is append it to new list. So new list dot append x. And then we can take a look at new list. And we can see here, these were the elements of the original list that are strictly less than 10. And our list comprehension from earlier works just as well. So notice we wrapped it in length just to kind of compute how many elements were in this list. But if I just say x for x in my list, if x is smaller than 10, notice we get exactly the same list here. Now, what I'm going to show you next is what I think is the most important way of being able to kind of generate these new arrays. I guess here we generated new lists, but kind of how this is going to work in NumPy is I say ARR, let's take a look at it first. And then remember, if I do ARR smaller than 10, what this returns is an array that has false everywhere ARR is greater than or equal to 10, and true everywhere that it's smaller than 10. So then if we do indexing of the form ARR of ARR smaller than 10, what this does is it says throw out 36 because that's false, keep negative 29 because it's true, throw out 42 because it's false, throw out 10 because it's false, keep 9 because it's true, and so on. So notice we call ARR of ARR smaller than 10, I get negative 29, 9, 5, negative 34. It matches exactly what we would expect. So like I said, this is perhaps the most important method of generating this array that you've seen today. So, and again, an example of what's called Boolean indexing. Now, we're actually ready to compute the probability now. So if we pick a random integer from such an array, what is the probability that it's smaller than 10? So first thing I'm going to do is let's update n to be, let's say 10 to the power of 7. And then what we're going to do, so remember now we have count here, and the way we estimate the probability is the number of successes over the total number of trials. So I'm going to start the count at 0. I'm going to count how many elements in my list are less than 10, and then I'm going to divide by 10 to the 7. So one thing I should do really quick, just because n has been updated. So let me go up here. So n has been updated. Now I have ARR. I'm not going to rerun this cell because it's going to be a very long array, but I'm going to rerun my list, and now we should be ready to go. So scroll down here. So then now how do we compute the probability? I take count and I divide it by n. And we can see here we get 0.59, about 60%. And if you think about it, that seems to be a pretty good estimate so far, just because, let's go back up to the original problem. So I have numbers between negative 50 and 50 inclusive. So that's 101 numbers altogether. How many of those are less than 10? 60. So 60 over 101, we would expect approximately 60%, and we can get the exact probability at the end of the video. So this is how we do it using the for loop. One thing, let's time it just to see how long it takes, and then we'll compare it to our other strategies. And I guess while we're waiting for this to run, I guess it's already done. So 812 milliseconds, a little bit under 1 second. So this is using the for loop method. Let's also time it using the list comprehension method. So let me go copy paste our list comprehension really quick. So remember here, taking length of our list comprehension tells me how many successes we had, how many numbers smaller than 10. And then what I'm going to do is divide this by the total number of trials, so n. And let's also do time it. And we can see here a little bit faster than the for loop method, but not too much faster. And finally, what we would expect is that the NumPy version is extremely fast compared to these two. So let's take a look. So remember, we were able to kind of do, what was our code for it? We had the count non-zero. So np.count non-zero of this guy. and then, so that's the number of successes. Let's divide by the number of trials, and we'll see how long it takes. And we can see here it took 6.67 milliseconds. So this was over 100 times faster than the other two. So we can see here just another example of how using NumPy is a lot faster. So you should use it when you can. Avoid using for loops and list comprehension if there are these nice NumPy methods. One last thing, so like I said, there were 60 numbers that were smaller than 10 and 101 numbers altogether. So if we do 60, oops, that's not what I meant to do. We do 60 divided by 101, we can see that's about 59.4%, which is exactly the probability, well, not exactly, but a very good estimate to what we got here in our computation. So I think this is a good place to end the video. In the next video, we'll start talking about logic in Python versus logic in NumPy. And thanks for watching. I'll see you there.